Alright, so in this lesson, we are going to be talking about exponents and division. In our last lesson, we had talked about exponents and multiplication, and we had three properties. And we're going to see some of those properties reappear today. We're going to start off with our first rule, which is the quotient rule. And remember, quotient means the answer to a division problem. So with our quotient rule, if we want to divide powers with the same base, then we're going to subtract. So when we did the product rule and we were multiplying, we added the exponents. Now that we are dividing, which is the inverse function to multiplication, so division undoes multiplication, then we're going to subtract our exponents. So subtraction is the opposite of adding, multiplying, or dividing is the opposite of multiplication, subtraction is the opposite of addition. So it's one way to help you remember. So then we have and we always write our generalization. So if I have a to the m divided by a to the n, that is equal to a to the m minus n. And so that's just, again, putting into algebraically what the words say, that when we are dividing our powers, we subtract the exponents. So now let's get into examples. Example 1, part A. We always start off, what if we have number bases? So if we have 8 to the 10th power divided by 8 to the 7th power, what we're going to do is we're going to keep the base. The 8 is going to stay there. Just like with multiplication, the base stayed the same. And then we're going to take 10 minus 7. So we end up with 8 to the 3rd power because 10 minus 7 is 3. And that's our answer. Our second example, when we work with variables, so y to the 13th power divided by y to the 9th power. I would then have y to the 13 minus 9, because we always move it up to the top. And 13 minus 9 gives us 4. So we get a final answer of y to the 4th. And then our third example for quotient rule, if I have 2d to the 20th, let me fix that one. 2d to the 20th power divided by 8d to the 13th power. Now, we've put those coefficients in. So remember when we were multiplying, coefficients are not part of the base. They are their own base. And so the base is just the d. When I look at the 2 and the 8, there are coefficients. And so if it's a fraction, I simplify. If I can divide evenly, I divide evenly. So if it was like 8 over 2, then the 2 divides into the 8 evenly. And we go ahead and do that division. Here I'm just going to simplify. So I'm going to write this as two different problems right now. Right now we have, or two different quotients. Right now we have 2/8 times d to the 20th over d to the 13th. That's what we have going on right now. And so what I'm going to do is I'm going to simplify the 2/8. That becomes 1/4. And then when I simplify the d 20th divided by d 13th, I'm going to have d to the 20 minus 13. And so then from here we have 1/4 d to the 7th power, because 20 minus 13 is 7. And so that's one way of writing your answer. The other way, since we started out as a fraction, is to keep it as a fraction. And so keep in mind that this d to the 7th is over 1, and so we would multiply across. So 1 times d to the 7th is to the 7th. And then it'll be over 4 because we'd have 4 times 1. And so either one of those answers will work. So again, quotient rule, as long as we have the same base, then we subtract the exponents. If we have coefficients, we simplify those and do the subtraction of the exponents for the same base. Alright, so then we have one more rule, and that is the power of a quotient. And so on this one, we will raise both the numerator and the denominator to the power. So if we have a divided by b, that's a terrible looking b, a divided by b to the nth power, then that is the same as having a to the nth power divided by b to the nth power. So when we work through this, a to the 7th over 5 divided by 5 all to the 3rd power. So what I'm going to do, I'm going to take this to the 3rd power, and I'm going to take it to the top, so I have a to the 7th in the numerator. So now I'm going to take that to the 3rd power, and I have the 5 in the denominator, and I will take it to the 3rd power. So I distributed it to both the numerator and the denominator. From here, I'm going to use my power rule. So I have a to the 7 cubed, so I'm going to take 7 times 3. So we end up with a to the 21st power over, remember that every base has an exponent. If it doesn't have one listed, it is 1. So I have 5 to the 1st power, so I'm going to take 1 times 3 and get 5 cubed. And so then there is our answer, except we should, Math Excel wants you to evaluate this. So a to the 21st, and then 5 cubed, remember, is 5 times 5 times 5, which is 125. And so then this is our final answer. And then one more example for tonight. If we have 2x cubed divided by 3y, and all of that is squared to the 2nd power. So again, I'm going to take my numerator, so 2x cubed, and I will square it, and I will take my denominator, which is 3y, and we'll square that. And now I've got a power of product. So again, this was from our last lesson. So there's an exponent of 1 with this 2. And so I'm going to distribute the 2 to each exponent. So now I have 2 squared, because 1 times 2 is 2. And x, 3 times 2 gives us 6. So 2 squared times x to the 6. And again, this 3 and this y have an exponent of 1. And I'm going to distribute the 2. So 2 times 1 gives us 2. So we're going to have 3 squared times y. And again, 1 times 2 is 2. So y squared. From here, we just have to evaluate. 2 squared is 4. X to the 6. And 3 squared is 9. Because remember, it's 3 times 3. So 9y squared. I can't do anything else because the x and y are different bases. So they just stay as it is. And this is our final answer. So again, on the power of a quotient, we just evenly distribute that exponent to the numerator and the denominator. If there are multiple things in the numerator, then it has to distribute to everything in the numerator, and same thing for the denominator. It has to distribute to everything in the denominator. Yes, you have a math Excel. Yes, you need to show your work, and I will see you next time I see you.